So we're the pickup team, and we will be reviewing reindexer database. So to start with, we kind of interviewed the customer. We interviewed the developers of the reindexer database, and during the conversation, he stated the most valuable quality requirements. As you can see, you've all seen them during the presentation, so I guess we'll continue. For this hackathon, we made a quality model of the reindexer database, and basically we like broke up, break down the three main quality attributes which were stated into smaller quality attributes, sub attribute, and we also tried to make the model look so easy that you could see the requirements for the project. Basically, if you could see, for example, maturity in the first line, it says like supports 50 concurrent connections. It means that the main idea of the project was that a database could handle 50 concurrent connections. Yeah, no other database could have done that at the point of research. So developers were like, we need to have a cool database which will be high loaded, very fast, but we cannot search for such. So we will create a new one, which will be called reindexer, and so. It was a business context, and the main requirements from the business context were, were implicated. Yeah.
So we create a list of quality requirements and static analysis methods and mapping it. So we have highlight majority with code coverage, and so next was time behavior, and it was related with benchmarks. So it used MRK framework, which work like Yandex time. So and modifiability connect with code complexity and duplication analysis. So that's it about mapping.
Okay, so we go to the quality attributes themselves. First is the performance, and let's see what developers done to ensure it is pretty good. So first point that they did pretty well is that they specified very explicitly what did they use on the performance benchmarks. It's like what was the device and the versions of language, like very, very detailed, so that everyone could repeat those results and ensure that they are indeed true. Then they specified what are the metrics and what performance they actually want. It's like up to 500K queries per sec for this query and so on. And finally, they performed the benchmark testing and compared their results with other databases. Everything is there on the repository. This was done pretty well, and no further analysis was required here. Then we go for high load stability. They also said it's like the most important for them. And yeah, some results could be taken from benchmark testing as well here. But also what they have is database replication, though it's not um, there by default. You need to specify that you want to use replication yourself, and you also have to find how to do it in README. But it is there, and it is in beta testing as well. So maybe this should be like first priority for them if they want high load stability. And also there are tests for replication there, though we did not include them on this slide. And finally, about changeability, well, this is somehow questionable. We performed static analysis. We'll show you results afterwards. And as the developer stated, there are no digital metrics they used. Well, what can we recommend? Try to use some cyclomatic complexity analysis or lines of code analysis. It is some metrics to understand how modifiable your code is. Yeah, I guess that's it.
So now let's see what checks we've done here to see the overview of the code from the static analysis point of view. We run two tools. The first one is SonarCube. That one is a free edition, so it doesn't contain any static analysis for C++ code. But there's a lot of Go code, especially tests. There are many tests written using Go. And well, here we can see that for the Go part of the project, SonarCube said reliability is an A+, security is an A, and maintainability is also A. Now we can see some security review says E, but that's mostly because there's some pseudo-random in the tests part of the Go code. And let's move to the CppCheck. That's for the other part of the project. Here we can see that the result of CppCheck is some kind of not really clear. There are a lot of errors, very many style issues and warnings and portability and performance issues. But we think that these results are not entirely correct. So we decided to have a better look at it and found some actual maybe styling issues. So these are the example of the issues that CppCheck found and that we decided could be included here because they're reasonable. The first one would be not explicit constructors with just one argument, then shadowing local variables that shadow the outer variables, and some styling things that could be done in a better way using newer standards, such as, for example, STD transform instead of using a loop. Yeah, such things. And the other one is included on a separate slide because we think that CppCheck was not so entirely correct in determining the actual type here. That's why it showed this portability error. But we think it's not entirely correct. And other than that, there are many errors that CppCheck showed, but we took a look at it and they are not irrelevant, basically. Now let's move to the tests.
So what about testing? Yeah, we've done all the tests that are in the repository. So we spend a lot of time to analyze how to run those tests because in the main repository README, there are no information about the particular test part. So we found out that from CI/CD, which was attached to the repository. And after that, when we finally found out how to run those tests, we ran them and found that some of the tests are failing because of something, and those tests are usually about request timeout. Yeah, and also about the testing system, there was a couple of issues we met while running. Probably it's because of the testing system itself, but not because of the particular tests. Probably something related with race condition, and it was in replication testing. Okay, go forward. Yeah, we've done the coverage, and it's pretty good coverage since it satisfies the rule of 80-20. So it's okay, nice. And here is a list of recommendations for like overall recommendations from us about the project. So first of all, yes, probably it's a better idea to list out those CMake options that we found out, because there are like different CMake files, and if you provide those options that are lying in CPP source file to the README, it could be a bit easier to navigate. And the next one is like, yes, add section about testing, because we've spent a lot of time going to the CI/CD logs and understanding how to run them. And yeah, section about build also important, because like I'm not sure, probably it should not run on Windows. And even for Linux, we had to figure out it from CI/CD logs. And about benchmark, like Postgres is one of the most popular databases. So probably it would be nice to add this database into the benchmark as well. So that's it. Thank you for your attention. Questions or?
Yeah, so we have 5 minutes for questions. First of all, I'd like the audience and the jury, if the jury wants to tell something. Etienne, Maxime, do you have any questions or particular remarks to the team? Artyom?
Not now.
Okay, so my question would be about your static analysis. So what's based on the static analysis? So what's would be your like final recommendations based on static analysis?
Well, actually, there were a couple of issues that our static analysis found, especially CppCheck. Yes, and probably so, like we list out some of them, but there are many of them. So probably like the developer should run and check whether those like recommendations, like minor style issues are.
I'd say that our recommendation, the overall recommendation would be that they do static analysis for styling issues, because there are many things that could be improved. There are newer C++ standards which could be used, and the code could be much better actually. But we're not sure actually which C++ standard was used there, and I don't think that we asked. Okay.
Okay. Also, as I understand, the customer wanted something about performance. So, what are your conclusions about the performance? Have you managed to test the performance of this open source project?
We tried to run the profiling, but there were some issues since like most of us were using like Windows, and running it from virtual machine, it was like kind of not the full power of the machine. And well, we made our assumptions based on the benchmarks that were in the repository already. So they are already pretty good, since they compare it with like different types of databases, and also they specify the hardware they are using, the very exact hardware, and also the C-lang also specified. Yes, the versions of the software are also specified, so we decided that it's not convenient for us to spend time for this part.
Okay. Okay, so last chance for the jury for the questions to the team. Artyom, Etienne, Maxime. So anyone would like to ask a question?
That's good.
Okay, then I would like to thank the team. Big applause to the team, please. Thank you, guys.
Thank you.
Very nice work. So we invite the best team.
Hello everyone, we are the best team and we are presenting the indexer project. This is the content of our presentation. Let's start from the product description. Our product is the database for the Wing system that is multimedia films search system, and it is in-memory, document-oriented. It has the speed of Taran to Redis and Memcache, and also have some complex queries with join and full text search. We have some insights from our customers. The first one is that their search in their database works with millions of documents. Also, there are no alternatives or competitors in Russia, but there are some competitors in other countries. And also the RPS is 5,000. About the quality requirements from the customer by priority. The first one is the high load stability, also the same reliability, performance, and changeability. And for these quality requirements, we decided to use DROMI quality model. About the correctness is the reliability, about internal its efficiency, and about contextual its maintainability. Let's move to the analysis methods. For the reliability, we use stress testing. For the performance, we use load and scalability testing. And for changeability, we use static analysis. And this is our results for reliability.
So here you can see our artillery results. As you can see, our RPC goes up to 6,000, and mean latency distribution is about 9 milliseconds in 99% of requests. So here you can see Apache Benchmark results. When we tested in 10,000 requests with 100 concurrency level, all was okay and was about 3.5 thousand requests per second. But when we tried to test it with 20,000, it fails. But interesting fact that if we add some replica sets, all is okay and 20,000 pass. And here you can see Autocannon benchmark. It's modern benchmark HTTP 1.1. It's written in Node.js. And here you can see that we achieved about 7,000 requests per second.
So about aggregation testing, in Reindex repo, there are a lot of like performance testing tests, but we didn't find some aggregation test benchmarks. So we decided to run some tests against Elasticsearch database, and you can see results about this. Yes, as we used like single node and without cache. And yes, if we talk about size compression, Reindex takes much more size for the same data set. Okay, about some words about static analysis. We used SonarCloud. We have the same results as previous team, so the SonarCloud doesn't give us ability to test C++ code, but there are about 22,000 lines of code and 20,000 codes of Go and 2,000 of Python. So this the results. Reliability bugs wasn't found. Maintainability also has good results. It has less than 5% of estimated technical debt, and 202 code smells was found. About duplication level, it's about 2%. It's normal level also. Okay, replication. We write some tests like black box testing about replications. We'll just default create several databases, one master and several slaves. We change some information in master database, and also information was changed in slave nodes. So it works okay.
Also, we discovered some bugs when we were testing our code. The first one does the rename endpoint, just overwrite another namespace if it already exists. And there are no warning messages or 4xx response. Also, responses in Swagger are incorrect for every status code except 2002. Sorry. In case we provide some invalid payload for namespaces, it will return some success, false, and response code 400, but namespace will be created. And also, when we work with Reindex database via HTTP, we may face some problems with trolling slashes. For example, in this case on the slide, There are different URLs, but the problem.
So we had several problems while installed our reindex on our machines. First problem was we want to use PyIndexer to use reindex, but we didn't succeed to install it because we had this problem, and maybe this problem with Makefile, but we didn't fix it. And also another problem, seems like the dependencies shell script file contains error in install host 6 because Brew may return warning for any of the packages, and script will be terminated, like it will show error. And this is how it can be fixed. This, yes. So time for Q&A session. That's all.
Okay. Yes, let's start with Q&A session. First of all, I'd like to ask jury if you have any questions.
Etienne speaking.
Mhm.
Yeah, one question about the bugs they found during the hackathon. By any chance, do they know if there are non-bugs, or did they find it by themselves and find the explanation by themselves, or do they find the bug and see it was well-known bug or documented bug and so on?
So yeah, let me try to paraphrase. So for the bugs that you found, did you found that in? I mean, did you check if it was already kind of in a bug list for this database or something? This was the question, Etienne, right?
Yeah.
We checked issues in GitHub, but we didn't found these bugs in issues, so we found it by ourselves.
Okay.
Okay.
Thank you. Okay, Maxime. Maxime, Artyom, do you have any other questions? Okay. Then I have a question concerning the SonarCube results. You have identified like 200 smells. So how bad it is? What exactly this smells signify? So what is that?
It's not bad because we analyzed about 22,000 lines of code, and it's not very big part. And also, this code smells mostly about like code style, some names, written in wrong style, like KMK.
So it's mostly styling problems.
Yes, but there is also some like commented out code that should be deleted, and it's not very big problem.
Okay.
Also, we have here QR code, and you can go for it and see our SonarCube results.
Okay. Also, here you actually mentioned that you have reliability with 0 bugs, and you found something like some bugs. I mean, how does compare? Whether that bug that you found would impact the reliability or not?
These bugs mostly connected with, I think, installation like process, because we, for example, problem with index, it's like problem with tool to configure and to manage database, but if we're talking about like reindex database, it's there wasn't bugs with work.
Okay. Jury, do you have any further questions? Artyom, Maxim? So probably my last question would be about your like I liked very much its comparison with other Elasticsearch. How relevant it is. Are they comparable, Elasticsearch and Reindexer, in terms of both are in memory, both are document based? So what's
Okay. Our member, maybe Igor can answer to this question.
Greetings. Can you hear me?
Yes, we can hear you very well.
Yeah. So your question was, are they comparable? What do you mean by comparable?
Yeah.
And you said that their both are in memory, but in fact, Elasticsearch not totally in memory.
Yes. And Reindexer is
So,
the memory one.
mhm.
So do they comparable? So because you compare like there is huge difference like between Reindexer and Elasticsearch. So
Yeah, but in repository in benchmark section, they compared Reindexer against many different databases. So we decided just to,
okay.
apply some more tests.
Okay. Did you run this benchmark, or it's something that you pick from the repository?
Sorry.
Did you run this benchmark, or it's something that you picked from the repository?
No, that's a custom written test. We developed, yeah.
Okay. Okay, thank you. I probably have all questions. Thank you, team. Very nice presentation. I think quite convincing. So, sorry? Answer? Another team. Okay, very Joker surprise projection for the audience, which should be also kind of. Yes, one last one. And then the other team, next team will be in DX7, and you should go and switch the equipment while the pickup team asks a question to Beth team.
We just use select from namespaces all items. Yes, here is a QR code where you can go and see all auxiliary results.
There was a script that fulfills the data in documents, so we used it.
Okay, thank you very much. Big applause to the team. Okay, so now we switch to NDX7 team, right? And yeah, you can start when you want.
Okay, hello. We are NDX.
Please speak into very close to the microphone.
Hello, we are NDX7 team, and we present our quality analysis on Reindexer tool, database like. So first of all, I want to start with some business context, some origin. That's why it's why it appear. So it's like Rostelecom was developed some media platform Wing, and they need some database, some maybe cache between their database. It's like, as I remember, it's Postgres. And between the client and they need a lot of requests per second. It's like 5,000. So and they needed to make some complete filtering. So it's like different filters, like categories of films, some location of users, and so on. And they try to find something that is suitable for them for these goals, but they didn't found anything because they tried. First of all, it's like was elastic, but it didn't give them a lot of requests per second. It's like 300, but if they take this way, they need around $2 or $3 million to buy hardware to somehow make this viable. So what's next? They think that it's too expensive and think, okay, we try to do something own. And it was like reindexer. It's embedded in memory, document-oriented database with high-level query builder. So it's it has speed of in-memory database and functionality from relation database like aggregation query, indexes, complex primary keys, composite indexes, join operation, full text search. And how this database use? It's like the most popular scenario is fast cache between relation database and client. Next is it can be like self-sufficient database. In the last version, as I remember, it's like replication and other stuff added. So and full text search engine. Where it's used, it's in Rostelecom, of course, 3 or 4 projects, as our customer said, and it's used in CityLink, Wildberry, Speak. So it's mostly Russian companies. Yeah, but it's I think it's really good. So go to our quality analysis. We took quality model ICO 25.10 and try to understand which are more relevant. So we have interview with our customer, and he said that it's most important is like reliability. So it's important to have stable performance under normal condition and high load. Next one is like functional stability and sub-characteristic functional correctness. So the product should work like it's expected from it. Next one is performance efficiency and capacity sub-characteristic, because we need some level of requests per second to have to withstand, to not spend a lot of money for another servers. I saw some interesting comparison that reindexer can operate on Raspberry Pi with 300 requests per second, and Elasticsearch can do the same on the server. So it's like the same performance, but its price, of course, is a difference. Next, maintainability, modifiability. It's important because it is a really active development goes right now. As I know, there are a lot of new features are coming, like sharding, clustering, and so on. So and new releases, as I remember, it's like in June, there will be. Performance efficiency, resource utilization. So it's like RAM usage, because for some requests, RAM is expensive. It's expensive, and it is important to have as small quantity of RAM for this as possible. And the last one is functions suitability and functional completeness. So we should have some set of functions like complex filtration, joins, and so on, to satisfy client needs. So how we check these attributes? First of all, about reliability, we try to gather and analyze information about issues in Git and Telegram channel. They have really good support team that operate in Telegram channel, and it's have much more issues than in Git, because they have inner repository that's not go in public. So, but in Telegram, it's really fast response you can get. Next, we supposed to have statistical analyzer and run execute existing tests. Next, functional suitability. We also analyze all issues that we had and try understand is it some features needed for customer, maybe some problems, how many are them there is. So next one is performance efficiency. So we try to redo some tests, stress tests that they suppose, and check is it true, is its numbers true, and we think that maintainability we can assess according to statistical analyzer.
Okay, we want to talk about next about the reliability. So what we found next on we are looking on the source code database. First problem is that there are many problems that collected on the Git. Almost a bit half of them is being closed. Active support for the product is only on Telegram channel, but released fixed bugs are in open repo every 2 weeks. If they consisted on the closed repo, maybe very often, not like an open repo. We also like to mention that if significant shortcomings, they are released as a hotfix, and always each commit has a CI running. Next slide, please. How we define the reliability in terms of statistical analysis? We used the SonarCloud analysis, and with that help, we can say that it has zero bugs in reliability. Next slide, please. By the running existing tests of this product, we can suggest that it had an amount 307 tests, which majority of them run and some of them may skip. And also you can see it here that we have 6 disabled tests. Next slide, please. As conclusion, we can say that by our work with SonarCloud, we can't find any analysis. From the amount of tests, unit tests in count of 307 passed successfully. And during the commit history can be found in GitHub, almost all found bugs have been fixed so far. Next slide. And what we're going to talk next is the functional stability of that project. We can divide it on several groups. We can find information about it. Telegram channel issues, GitHub open issues, GitHub open close issues. By the division, we can say that for the majority of them, issues was in Telegram channel because it's considered as a fast way of communicating between people nowadays. Bugs as the closed issues in GitHub. As you can see, that 55%. And the suggested was equal GitHub because it's easy to track them on the issues part of GitHub. Also, we suggested that metric of functional correctness, it will be number of reported bugs, but seems as was logical and usual, understandable for each usual people. Next slide, please. And the conclusion we can say for functional stability, in total we found 20 proposals and mission functionality, which can be considered the next releases of the product. Several features that was anticipated, for example, sharding of the several issues of the product. And the for correctness, we can suggest that for the complex products, 35 bugs is not many. It can be 100, but it's not. And these bugs are fixed on a regular basis. It's very good for such a big product. So, next slide.
We wrote some stress tests that showed us that the index is okay. And that's all. It's okay for our stress test. Next slide, please. We can't repack some stress test to compare it with reindex with Taranto and Redis, and some values on these slides we use from our benchmark. This is a result of the test that show us the amount of RPS for reindex, for Taranto and Redis. And you can see that the filter with votes, 1 vote, 2 votes, or maybe updates, show us that the reindex is the best from these softwares. Next slide, please. On this slide, we provide fast search with complex queries. And based on this test, we made conclusion that the between Elasticsearch and Sphinx search, reindex was the best too. Next slide, please.
Okay, yeah, I will proceed with maintainability and modifiability as subcharacteristic. So we made statistical analysis and had like 3 days technical depth and 135 issues with maintainability. As you can see, it's like 47 critical issues, and it's mainly about cyclomatic complexity and cognitive complexity. So it's hard to analyze this code. It's like I saw cases with 150 when 15 is like threshold. So, and you can see that, of course, it's like only Go tests, and you can see that most technical depth files, models, it's like CJSON. So it's like outer model, outer component, decoder, encoder. So it's like one third of all technical depths. So we can see that if they want to do something with it, it's a way how they can. So in the conclusion, yeah, technical depths not so big. 3 days, 3 working days is not so much for such project. It's mainly related with cognitive complexity. So, but that we found it's not only from statistical analysis. We found that documentation is not comprehensible. Some issues missed, and we found some issues with it. Some in a Telegram chat, we found some messages that some issues we found in issues in GitHub. So some issues with documentation there are. Yeah.
And our conclusion, there is no significant reliability issues that we could identify. There was some issues with functional suitability, but they are not so serious. Reindex has good performance compared with the other competitor. for example, Elastic, Tarantul, MongoDB, etc. Reindexer has minor issues with maintainability, and based on it, we can conclude that the reindexer looks like the best solution for now to use as fast search with complex queries. But the company that want to use reindexer should answer some questions before implementing reindexer. For example, scalability, how quickly it will be possible to add new service to the existing system so that the search engine itself distributed to all. For example, the second question maybe will be with multi-tenancy, the ability to organize several search in one object. For example, it will be when the search for all visitors doesn't have to be identical. In fact, quite often the situation arises when there can be more than one search engine, and there are either multilingual system or system with certain numbers of users who need the ability to search with personal data. And for example, the last question maybe will be, do I need to build indexes for different languages separately, adjust monology or some search parameters when I want to improve my search in the documents?
Okay, we have
Thank you.
Here. I'd like Jury to ask questions. So Artyom, Etienne, Maxime, do you have any questions about the analysis? Okay, then I would also ask a few questions. So when you said that performance is kind of good for reindexer, what did you mean? Why you think the performance is what you could actually witness?
Okay, I try to answer. First of all, we compare in different categories. It's like we compare with Redis and we compare with Tarantul as in-memory cache. So it's like the similar solution. It's near competitor.
Mm-hmm.
So, and we compared with Elastic and Sphinx because it's tools that allow you to make full text search.
Okay.
So, and you can see that in these two different categories, the reindexer is much faster.
Mm-hmm. Okay, thank you. Probably very last question. Jury, do you have any specific question for a moment? So if not, we thank the team NDX7 and invite team Клуб юных любителей качественного аналитического кода to join the stage. Okay, thank you guys. Big applause. Yes.
Раз. Can you start? Good afternoon, everyone. We'd like to present our version of software quality and reliability for Indexer project. Next slide, please. So these are quality models we took from the client's presentation. We actually mentioned functional suitability. We also got into usability, reliability, portability, and efficiency. So let's go over them one by one. So functional suitability. We mostly focused on the practical side of using the system. So we try to focus on different connectors to the server, as we have no or little experience in C++ implementations of the server or the Go implementation of the client. So we try to focus on multiple connectors and how well they behave. And we wanted to compare what is their expected output and what is their actual output. Can you go next? Yes, so one of the main things we actually tested is REST APIs, as I think probably most of you might agree that search engines are mostly used in web applications, and we typically connect via REST APIs from our phones or from our web browsers. So we try to heavily focus on REST APIs, and we kind of found some inconsistencies between documentation and the actual work of the system. Most of the inconsistencies actually related to the fact that some requests and some responses were not as they expected. Can you go to the next? For example, we tried using several endpoints, and we got some weird error messages. And as you can see by response code, this is 500 messages. So these are some messages which are not really expected. Can you go to the next? And we also got some 400 messages, but error descriptions were not really understandable for us. So some endpoints just behaved quite weirdly. Can you go to the next? We wanted to test gRPC. However, we couldn't manage to, but the API looks quite fine for our tool. Can you go to next? Go library is probably the most well-documented and has most of the examples, and we didn't actually find that much bugs there, so it was very well tested, and there are lots of test cases, and the interface is really well documented. So we expect suitability to really be high in this connector. Python connector, it wasn't just simple. It wasn't really simple with Java as well. So Python was not really worked on. So we discovered that it's really hard to install, and we didn't even try to use it really correctly since we had some problems even installing it. Next one. Java, no. So yes, next one, please. So let's move to usability scores. So these are the scores we actually came up with to two connectors of the system. These are the REST APIs and the user interface, which is a little bit weird for some reasons, which I will mention later. So REST API score is 6.5 out of 10 for usability, and user interface is 7 out of 10 since, can you go to the next slide, please? Yeah, so let's just mention some general points for usability, since we focused really heavy on usability. Installing was, at some points, it was really easy. At some points, it was really difficult. So for supported operating systems, installing was really easy. And using it was also easy as well. But for some Linux distros, like Arch Linux or Kali Linux, it was not supported. And we couldn't really find in documentation that it was not supported, or we couldn't find any ports to these operating systems. Also found that version for Windows is different than for version for Docker. So we think this is a major inconsistency. This was not only minor version, but this was major version. So you can see 2.9.1 for Windows build, but 3.1.0 for Docker build. And the interfaces are quite different. It's not really intuitive how to actually start with the system. So we couldn't really find it in the docs. We had some we had some process going on how to install it, but there were no really next steps, and it was not intuitive. But we needed to go to some port, or we needed to manually start or stop something. But we actually found a nice addition here. Telegram channel was really supportive, but I think this is not really a professional way to deal with questions. I think we should probably document some issues in GitHub issues or other sources of bug trackers, but not really Telegram. User interface. So yeah, so these are the differences between major versions. Interface version 2.9.1 was really intuitive. But when we tried using 3.1.0, it wasn't really intuitive. It had probably more functionality, but we couldn't do the simple task with it. So yeah, just stick to 2.1 to the 2 version. I just discovered that most of the user interaction is really, really simplistic, and only notification can say that something is wrong or something is correct. And this notification goes like 5 seconds and you don't see it. So, however, the error messages were really good. And of course, lots of features are not present in the user interface. REST API was kind of impressive. It had really good response time. I was really impressed as a usual user, as not a load tester. However, there are some drawbacks to it. One of the major drawbacks is that a lot of stuff is not documented enough. There are no guides or no examples how to do some features. And one of the worst things about this is that full text search is not documented at all. We found some small guide, but this guide didn't explain a lot of details how to actually work with REST APIs. So we had to manage this ourselves. We had to actually dive deep into the code to understand it. This was really a big pain. And that's the reason for such a low usability score for REST API.
Reliability. So the plus is that you have a lot of tests, especially for Go. Also, you have active community that search for some bugs for you and make an issues. And such issues are solving for time. But you have failed pipeline in many commits, like in 30 or 40%. So I definitely think you have some problems with pipeline. Also, you have some issues that were closed without any comments, and some issues some issues are since 2018, and now it's 2021. So I don't know. Next, portability. You have many supported operating systems, and that's good. You support Windows, Mac OS X, and some Linux distributions. For example, Fedora-based and CentOS or Red Hat based. But also you don't support many Linux distributions such as Pacman-based, for example, Arch Linux and Manjaro and so on. Some Debian-based like Kali, OpenSUSE-based, and other less popular ones. We tested it on Manjaro and Kali in our team, and it was half our team, and we couldn't use your product. But we could use it through Docker. And also, as we already said, Windows version is outdated for 10 months since June 2020. Also, there are some customer-defined quality models, such as performance, stability, and changeability. So firstly, performance. We use stress testing through artillery. And here is some graphs. For example, here are total input and output RPC HTTP traffic for each database. And there are amount of dynamically allocated memory according to TC malloc and GE malloc. And it looks nice, but we didn't find some metrics that was included in documentation. For example, average latency and queries per second total. Stability. As I already said, we used stress testing via artillery, and testing was in 3 phases. Firstly, warm-up with duration 60 seconds and arrival rate as 5. Ramp-up load with duration 120 seconds and arrival rate from 5 to 120, and sustained load with duration 10 minutes and arrival rate 50. But during stress testing, the server was failing, which hosted Reindexer. So we were not able to adequately test it, but it looks nice as our server was failing, but your product is not. Changeability. It was quite difficult in a few hours to assess your architecture. So we just looked only in your commits, like some latest. And we found out that inserting one little feature didn't affect many places. So I think changeability is also good enough. And also we found a lot of typos in your README files. So we fixed them and made a pull request. Thank you for your attention.
Okay, thank you very much for your presentation. Interesting. So I invite the jury to ask questions. Etienne, Maxime, do you have any particular questions?
Yes, I have a little question. Thank you for your presentation, first of all. And I'm very interested how you install Windows version of Reindexer with 2.9 product version.
It was binary version from the site.
It was a binary downloadable 64-bit version, which is in your documentation.
Okay, thank you.
Okay. Yeah. So my question was, did you use static analysis for like maintainability or changeability?
Not really.
Oh, okay. In terms of usability, so what are the main points that you found? So what's kind of the key findings?
The key findings is that documentation is not complete, and as a developer and as a primary user of this system, it's really difficult to use the system because documentation is not complete and you cannot actually develop. The key concern was that full text search is not documented enough, and it's one of the most important features of the system.
Okay, well, very interesting. Okay, jury, Etienne, or others, do you have any more questions? So otherwise, I thank you very much for your presentation. Very nice. Big applause, guys. So, and I invite IEEE CSPAS team to join the stage and join Zoom and start the presentation. Join Zoom session, the one that I sent this morning. No. Use microphone that is on the table, which is always on. The microphone is always on, and you just speak it and speak to the microphone, please. Okay, so start when you're ready.
Okay, let's start. That's our results for these five hours of playing. Here you will see our team members. Regarding info from customer side, there was not so much info, but we quite got the point of a customer. So just should check, is it worth to use CSPAS? Check security, we have some limitations, some requirements for CSPAS about persistent connection, persistent users at one time. And let's start with issues. The first and quite fun issue that we found at first is just that admin could delete itself, and if there are only one admin, application will be dead because no one could create new users or do something of that. There are concepts with master key, but it's quite unclear because everyone needs those master key, and like idea of this key is missing, and master key is similar for everyone. You could generate some temporary master key, but we didn't manage to find this feature on the build. And actually the first that we also called code that built on master branch is failing. About backups, because in this case backups are quite important. In documentation, we found only one way to backup, and it's just to copy the database and configuration files, and that's it. But there should be additional backup strategies, but maybe they're still not working or not documented. About security, if you're an admin, you could see, actually you have a way to see a password of each user, saved passwords in this service. There is just some strategy how to do it. Actually, there should be some mechanism to avoid those cases when admin just changing someone password to login into their account. But this case avoided if we change password 2 times. Because when you log in with a new password, you need a previous password. And if you change password 2 times as an admin, you could just use these 2 passwords and log in for any user if you want. And we actually broke on the demo site. There is demo user, and at demo site, there is a password for demo user. We logged in via demo user, created admin user, and changed the password for demo user. Maybe we will show even now. That's for example, there is a username. There is default password. And if nothing is resetted, invalid action. Maybe it will work with our demo. But now it even didn't work. Just we'll try to be quite faster, but okay, again, demo, default password at the demo website, and wrong login. But with our changed, it should work. That's it. Even the demo site doesn't secure at all. Both general impressions, we found some quite low usability, completed documentations, and at some point it's quite hard to navigate or figure out how to do how to operate with the system. And about concept, as a user, you could just create some pairs of user name, password, and some additional information, and easily see it without any additional protection for specific passwords. And is there any reason to do it in such way? We don't know. About code coverage, it's about 55% of line coverage, 50% of methods coverage, and so on. Not good, not bad, but in case of such sensitive software, it should be maybe higher. There is some reports from stress testing and Apache Benchmark. And as we could see, the response times are quite long, quite high. Okay. Artillery report, but we got a lot of timeouts on 1,000 requests. So maybe not so good. About UI, about validation on front of some values. For example, when you see it for first time, you don't understand what should you put there. You can put 9, for example, number 9, number 10, but at some point you could put minus 900,000, and it will work. And another examples where you just put some number and it says that maybe you should put some valid values between those and those, and no any limitations at the front. About SonarCube, don't look at the coverage on the left, or on the right downside, or the left downside, because it didn't connect it with SonarCube, but we showed the test coverage in the previous slides. But in general, there are a lot of depth and bugs, but some of them, as we assume, comes not from the software itself, but from libraries that's included in code. But about critical points, we are not security experts, but at least we trust the SonarCube. And there are a lot of encryption, cryptographic algorithms that use some SHA-1 and MD5 And SonarCube tells that this is not secure in sensitive context. And there are cases where it is not secure, but it's user password storage, and so on. And in our case, we're working with password storage software. And as a conclusion, at some point, UI may seem nice, but many other points are quite untrusted, but or seems incomplete, or just there are some missing features. And there are no any positive points. We didn't found them in such software. Okay, it's time for a Q&A session.
Okay, very nice results, guys. Interesting. So I pass the word to jury. Maxime, Evgeny, Etienne, would you like to ask something?
Yeah, Etienne speaking. Maybe I miss it, but how do you test the front end, the UI interface by hand, or
Did you test that UI interface by hand or not?
how do you test it?
Yes, we just checked a lot of stuff by hand because it was, in our case, the fastest and simplest way to do it. Some kind of with box testing of but we don't. We played a lot with it, and there are the issues that we shown with, for example, UI. There are actually, I think, quite bigger list of them, but we put some most interesting or significant.
Okay. Evgeny, Maxime, do you have any more questions? So my question would be about the technical debt that you identified. So what is it is related to?
In general, about technical debt, I think that SonarCube just analyzed external libraries. So maybe the technical depth here is quite less than it seems. Just a little code. Because it looks like some yes. But actually there are a lot of internal depths.
So okay, so this is it's more styling errors or something more serious than styling?
I think in general it's PHP. We don't know about styling, but we could check that. Yes, looks like.
Okay.
Yes, some. In general, there is some, like some more than styling.
Okay, so in terms of performance, you mentioned that you would like to check for thousands of simultaneous connection. Did you manage to? So what was your report with Alternative? So I couldn't get too much of it.
In general, the response time is quite high.
Okay, so the response time, you think? So what was kind of average response time or maximum?
Okay, as my team tells me, that's about 20 seconds in average.
20 seconds on average for on which environment? So what was the computer? Can you speak to the microphone, please?
It's a
local installation on
local machine.
Local machine, which is
Notebook.
Like Core i7 or I don't know.
Yeah, 4 cores.
4 cores CPU. Okay. Okay, and how many simultaneous connection?
100.
Well, 100 simultaneous connection, 20 seconds of response time. Okay, which is kind of nonsense.
But some connection was 500 seconds.
500 seconds.
Yes,
okay.
and average maybe a little
trigger if some
Okay.
connection better.
Okay, so it seems that it's very good software for testing, let's say.
There are a lot of interesting stuff in those
Okay.
software.
So, yeah, okay. Great. Jury, do you have any more questions? So, otherwise, big applause to the team and applause, please. Thank you. Yeah, so, and we will now switch to DocRec team. Okay. So like connect to Zoom and present over Zoom, and you can also use microphone over there.
Hello everyone, we will introduce our project, CppCheck Quality News. First of all, I will introduce our team. Daniil, Valery are developers, Timur analyst, and we need to notice one disclaimer. We not have informational security skills. It's an important information in the future. And a few words about our customer. Numidi company is a group of company that has a digital medical platform for medical staff that includes multiple participants in one environment, real-time control and feedback, single information space. And what about our project goal? We need to help make decision for our customer. Should the Numidi use CppCheck in their IT environment? And about project boundaries. The system shall contain password from accounts in one system, and the system shall be able to internal users with IT competence, for example, IT supports, IT architecture, IT, developers, and other. Few words about CppCheck. CppCheck is a password manager system that based on PHP web technologies and use IS 256 encryption in CTR mode, and it's enough. Let's continue, Valery.
Thank you. So let's start from the GitHub repository. It starts from the 2012. It contains more than 100 releases, but only 4 last year. But it's but for now it says that it's still active, but not like such active like in past. It has 168 open issues and more than 1,400 closed issues. But according to the history, all critical issues like XSS attack possible closed in 2 days maximum, but usually 1 day. Next slide, please. So we use quality model ISO 25010 and select most appropriate quality models, quality attributes, and prioritize it according to the customer needs and our expertise. So let's go further. So the first one is integrity. It's about like someone can get or delete or manage our information without access to it. And the main fact here is that the database is encrypted. Not all, but the intruder cannot get the passwords if he get the dump of the database. Because he need to decrypt it, and for it he would need the key and system key and the master pass and sold from the app configuration. So next slide. So confidentiality is implemented like splitting different access categories to different groups. We cannot find the scenarios when one user can access to the other group or change a password from admin and so on, but we can guarantee it. So authenticity implements like basic login, but also it is support two-way authorization, but it requires some plugins, and about it we will speak later. And the last one about security is accountability. It's about how we log our measure system changes, and SysPass have this feature, and it logs all config changes, so no one go silently. But it doesn't show other measure as we think changes like main admin password changes. So someone can change password of admin and no one see it publicly. So next one. And capacity, I think Daniel will help.
Yeah, actually we measured how much memory used by one account stored in database, and it's about 8 kilobytes. Then we assessed maximum amount of data that can be stored in database. It's about 16 to 2056 terabytes, which is about infinite amount of passwords that can be stored in database. Next slide, please. So installability. Actually, system comes in Docker container, which can be deployed very fast without any special configuration. So system administrator don't need to know some programming skills, and there is also options to install on Linux like Debian 9 and CentOS 7. Next. Learnability. Actually, we learned how system works in about 40 minutes, and I think it's enough to teach some new users. So we know that our customer have around 100 of employees. So, and he can study them very well. So a lot of testing. We tested our deployment in Docker using Yandex Tank, and graph on the right side shows that as much requests per second we give to the system, then we get more latency, like from less than second to thousands of seconds. And graph on the right side shows that threads used to process requests is not linear. So, and problems with performance, we began with about 150 users. We made a static analysis using SonarCube. We found 3,079 bugs and 124 security hotspots. Actually, not most of them are not so important as SonarCube highlighted us, but some of them are really can be critical. For example, this is a set cookie call. Don't forces browser to hide from JavaScript scenarios in the browser. And it may allow some attackers to steal cookies and log in as a user that were involved in this attack. And it's also showed us that there is some possibility to steal data using some domain that is different from original server. So, but not all security problems were found using SonarCube. For example, we found that it is possible to make SQL injection using these parts of code. For example, you can see that in set where function data not checked and just put into query to the database, and then it can be used. Actually, it's not a problem. Yeah, it's not a problem because system handles itself these cases in other parts of the system. But if we use, if we add plugins to the system, so we have to check if they are really safe, because this code can be involved to make some attack. So our recommendations is to use Docker containers because it's already configured with secure configuration. Use the system only in local infrastructure because it can be vulnerable from internet sites. Do not use plugins because some code allows to use them for data to hack into system. So, and use directory access protocol, for example, LDAP, to access users. And our customers said that they have security department, yeah, and we advise to use this department to make more deeper inspection. So that's it. Actually, we have more slides, but I think we are out of time. Yeah.
Okay, thank you very much. Very nice presentation. Yeah, well, I would like to ask jury if you have any questions, please. Etienne, Evgeny, Maxime. Do you have any questions? Etienne, okay.
Yeah, a question. I found the security checking really interesting for this type of software. How did you perform the checking? Did you use external tool or methodology, or just looking at code? You used Sonar, but it's not known for security. What kind of tool, yeah, do you use for security checking, if any?
Actually, SonarCube have some checks for security, but
Okay.
it's not fully specialized into security. But yeah, as you can see, there are security hotspots that it's checks that done by
Okay.
SonarCube.
Okay, so if I understand right, SQL injection part, this is what you discovered without SonarCube, right?
Yes, it was Find by manual check.
By manual checking. Okay,
Yes.
good. My question would be about performance. So you found your kind of finding is that starting from 150, it start to deteriorate quite fast. So at which level do you think it's still usable and response time is still kind of acceptable?
So as you can see on this graph, on the left one, yellow it's acceptable. Orange and red is very slow. For,
so I can't read that very well. So how many users then it would be acceptable? So starting.
So here we can see.
Yeah. So how many users? For how many users it will be acceptable in terms of performance?
We check it for the first. We check it for the 15 users, and 15 users can use the system without some problems. 15 users online, but our configuration in the local machine able to use 80 users.
80 users was still okay?
Yeah.
So so it means that this 80 users needs to be kind of querying the system simultaneously, right? So so if there is 100 or 1,000, but they do not use that simultaneously, that might be
they face some problems.
bearable. But if they all together use it right in simultaneously in the very moment, so that's really the problem.
Yeah, but in our configuration, in this case, some users will authorize and search the accounts in the system. We test only on this case. It's simulation tests.
Okay,
synthetic tests.
I see. Okay. Any more questions from the jury? Evgeny, Maxim. Okay. We thank you very much. Big applause to the team. And now we have the last team with Apache POI and open-minded team. Okay. Ilyas, please connect to Zoom, share through Zoom, and use microphone to speak, please.
Can you hear me now? Yes. Well, okay. Okay, I think we can start with the context. Modelio company needs some tool to generate and reverse Microsoft documents such as Word, Excel. So they are interested in Apache POI for doing such tasks, and some usual cases which we found out from customer, it's such as table inserting for Word document, picture inserting, specifying headers, defining them, hiding rows, and etc. So let's go further and see how Apache Poi dealing with that. We will start with functional suitability. So, well, Apache Poi has several components for Excel, Word. So here is the table for it's so it can be, well, here it has various functions such as read files, writing, and styling cells, deleting sheets. Well, it's kind of simple stuff. It's all so it can work in memory, well, in client's machine. And this in memory mode, all structure of the Excel will be hold in your RAM, and the second one is streaming. It's reading part by part the document. So writing in this case it's not supporting. So if you are caring about RAM, well, the only option is streaming and only for reading. So be careful with that. So yes, the limitation is yes, memory usage, and such tool can't produce well charts. Well, it can, but limited supporting. And it can do some simple chart types. And it doesn't have fully support for creating pivot tables, but such simple stuffs, it can be done. Well, let's start, let's continue and see how usable this tool. So about documentation for Excel, well-written documentation. There are some quick guides how to do some such simple stuff with examples and instructions. So formal support examples and etc. So well written. For Word, it's a bit less information than for Excel. And of course, there is some example source code you can see. We found about 9 examples for Word. I tried to run it. Everything was fine. And you can also use unit tests. It's a requirement from open source community that if you supporting these projects and adding some new stuff, you should provide unit tests. So you can also use it with for additional examples. So about community, well, there is developers discussions with big amount of users, and of course Stack Overflow. It's a rich community with you always can find any resolution for your issue, and of course it's a well studied instrument, so also you can attend some courses that are pretty much available. So Jordan will present reliability of this tool. Jordan, please.
Hello, everyone. And when we start to evaluate and measure the reliability of the product, we first of all, we should find some metrics and some statistics about the product. And we found that there is the Bugzilla store, which in which developers and users can store some similar bugs and issues. Next slide, please. For example, in the chart, we can see that first of all, I should mention that Apache POE supports two kinds of ports. First one is Microsoft OLE to component document format, and second one is Open XML format. In that blocks, there is a two ports for Excel, Word, and PowerPoint. For example, there is more bugs for the Excel. It constitutes 35.7% of bugs. And in the second place, it's also XSSF. It's also the port for the Excel product. It constitutes 19%, almost 19%. Next slide, please. There is a issues by status. They have the legend for bags for each new create bags. For example, they have status for that, and for example, there is a new status, close it, resolve it, and reopen it, and need more info. When users open new issue, status will be set to new. Well, and when developers and contributors fix that issue, that back place to resolve issue. You can see that there is more resolved issues. And in the final stage, after verifying the QA team, the bags place to closed status. And we can see that there is a lot of resolved fixed bags, but the QA team is not verified yet. Next slide, please. Here we can see that issues for products, for example, for Excel, and it's HSSF. It's for Microsoft OLE2 format. It supports Excel and Word documents until 2003. And second one, it's XSSF format issues. It supports Word and Excel 2007. Here we can also see that we have more bags for result status, and also we have a lot of new bags. And one thing which I should emphasize that some bags very older date, for example, and there is no any contribution to fix these bugs. For example, there was a bugs from 2010, 2008. Next slide, please. This one is this chart show that two types of products. So for Word, here as well, we have two ports, Microsoft OLE and OpenXML. And we have more bags for the OpenXML port. Next slide, please. Issues for Word ports by status. Here we can see that also a resolved bags, a lot of percentage here, and closed bags, QA team not verified most of the part of the bags. Next slide, please. Now we can tell about the portability of the product. We test the product in the Windows operation system and Linux. And in both cases, we have success result, and but Unfortunately, we don't have OS6 machine, and we cannot test in that machine the product. And system requirements. The system requires the JDK Java Development Kit, and for 1.5 or above versions, and requires 1 GB RAM, and operating systems Windows XP or above, and Linux. Next slide, please. Installability. We test the installability attributes with Java technologies. For example, it can be installed with Maven, Ant, and Gradle. And there is a versions which requires different versions of JDK. For example, Apache 4 requires 1.8 JDK or later. Next slide, please. Replaceability. When we plan the test the replaceability of the product, we try to find the alternatives for the project for this system, and we found that two alternatives, direct alternatives. I mean, that two alternatives can work with Microsoft systems, for example, Microsoft Word, Microsoft Excel, Microsoft PowerPoint. First one is docx4j. It supports Word, Excel, and PowerPoint, but it doesn't support Visual. And second alternative is FastExcel. It's really reliable and with high performance library for Java systems. But the only limitation, it only supports working with Excel. Next slide, please. And so we have indirect alternative for the Apache POE. It's JOpen document. The limitation for this library is that this library can work only OpenOffice editor and supports text documents and spreadsheets, but cannot support presentations. Next slide, please. Okay, efficiency. Now, Ilyas can continue.
Yes, we try to test efficiency. We some kind of implemented, used some stress testing. So, well, inserting table. So we tested Word, inserting tables in Word document. Let me clarify that we inserting one table with 7 columns and 20 rows. All cells has contained tests, and so such units, tables, we inserted about 227, and it takes 1.5 seconds, so pretty fast, I think. Next is we tried to test Excel, his efficiency. So we found out that some formatting functionality is kind of heavy for that library. Anyway, modifying height of the rows for Excel, it's for 4,700 rows. It takes about 6 seconds for doing that. It was some kind of randomly changing the heights for rows, and as you can see, it takes about 6 seconds on my laptop. And it's for after sizing heights of rows, it's for same rows, it takes less time. It's about 2 seconds. But from my opinion, I think such a number of rows from business context, well, it's too much. Well, I think for documentation or generating reports from Modelio, I think that's kind of good results. So that's all from our side. If you have questions, we'll be glad to answer them.
Thank you very much for this presentation. Yeah, I'd like to ask questions from the jury. So, Etienne, Evgeny, Maxim, please.
Yeah, Etienne speaking. Could you come back to the instability slide, please? Instability. Yeah, that's it. So, by instability. Okay. So you used. I was a bit confused with this title because instability for you means possibility to be installed. Yeah.
Yeah.
Okay. Sorry. I was more on stability of the. Okay. That's good. Sorry.
Okay, then I'm probably, well, in this installability issue, do you think it may work with Java 11? This one?
Not yet.
Do you think POI is not compatible with Java 11, right?
Not fully compatible. Yeah.
Okay. Okay, so this is actually quite important issue, I guess, for Modelio team to consider. In terms of performance, could you go back? But why do you think that it's reasonable or not reasonable, the numbers that you've shown?
Well, I think we tried to some kind of simulate usual use cases for generating document. Well, I think for generating document, some kind of formatting is can be used by this tool, and well, inserting text, and we just wanted to see how this tool is dealing with that and with a big number of such operations.
Okay, thank you. Yeah, I think we can close right now. Thanks the jury. So we'll be gathering for award ceremony and announcement of the results. Jury, please close the voting as soon as possible, and we will ask all other people to join us in the room. So I think we will start the award ceremony really in 5 minutes. So please stay in your places. Can you ask others to join? Okay. Okay, so yeah, so we are at last point of our hackathon, right? So did you enjoy the hackathon? Is it better than exam? Is it better? At least for food, right? So it's different. Yes. So I actually proposed to several professors to join our forces in the hackathon, but I couldn't make it this time. Okay, so okay, so I think you are wondering who would be the winner in each group, right? What were the notes and everything, right? So, or you're just hungry. Okay. Okay, let us see. Okay, we have a lot of votes, and I actually thank very much the jury because I mean they were devoted and stayed here with us, and we had at least 4 votes for each of the teams, so we have somehow a good representation for the teams. Okay, and so I applied this weights that you remember. So 40 for the first question, like understanding business context, quality model, etc. Second parameter, what was the methods they use and the soundness of the analysis, and the third one for the presentation, right? So first parameter 40%, second parameter 40%, the last one 20%. So the first two overweight the other one, right? So, and let us then see what I have in 2 groups, because we will have 2 winners. Winner on the one group in the room 307, and the other one in 306. Right, and let me share my screen, and we will see who will be the winner. Oh. And the room, let's start from, yeah, room 307. So who will be the winner? Okay, you can test it by yourself. Okay. So who would be the winner? It looks like another team would be the winner. Big applause. Okay, guys, come here. So stand here. Okay, room 106. Would you guess who would be the winner? Any guesses? Any guesses? Best team? Best team was a kind of good one, yeah? So the other teams was also good. So who will be the winner? And he will have the final numbers. So who would be the winner? Wow. It was really close with Index 7. Okay, guys, congratulations. Please come to the podium. Okay. So what do we have for the winners? So we have 2 professors who to cheer you up. Okay. So to have nice photos with the professors, right? Good. Better than nothing, right? So what else? Okay. First of all, for all participants, we have certificates of attendance. So you guys, all of the winners. So for those who need, we have specific certificates for attendance. Okay, you can pick it during the pizza break, let's say. For you guys, we have special winner certificates, but they are not filled in. So we didn't know who would win, you know, and we didn't have time yet to fill this in. So I will have to fill it in. And it's already signed by our direct and professor. Yeah. Yeah, we didn't decide it before, right? So, but you see there is master students, bachelor students, kind of, yeah. But no suspicions. Yeah, proof legality, nothing written on these certificates yet. Okay. So, so we prepared some nice prizes for you guys. So you are officially black belts in SQR, or black t-shirts, let's say, in software quality and reliability. and analysis of software artifacts. So, I mean, let's again, thank you. Okay, thank you. Very good job, Anton. Yeah, here you go. Valery. Yeah. Hi. So, yeah, okay, and Daniel. Okay. Thank you, guys. Now I think we can move to the pizza party because it's, yeah, photographer, do you need something? Any photo, specific photo? If you want any specific photo with our guest professors, so you can ask them during the pizza party and we'll have them to help us. Yeah. Quality. Yes, yes, please, ladies, ladies first, come on. Yes. Valery. Okay, thank you. Do you want two? Because it's too big to you. For two, you can. No. Okay, so would you like to give any comments, or Joseph, could you like to give the comments about the rooms, how the other, let's say, ambience in the second room that I couldn't manage to visit? It was dark. Okay. Anyways, okay, it was dark, but it's finished, and now we can go to pizzas served in the hall. So please enjoy. Thank you very much for coming. I think that was a nice experience, right? Okay. Yeah, yeah. So the Geraldine, thank you, and those who attended online, I thank you all very much. Bye bye.